Okay, this is problem number 8 in your optimization packet, which I did warn you is a little tough. This is probably the hardest one in there. So I'm going to try to help you with the setup of this one. Pretty simple scenario. We've got a wire that's 24 inches long, cutting it into 2 pieces, so we can cut it anywhere along the length of it. One piece is going to be made into a square, the other piece into a circle, and we want to know what would maximize the total area enclosed by the square and the circle. So they kind of set it up for you, if you look at the picture, that the wire is going to be cut at some point. They're going to call this first part X. And then, well, actually, we could call either one, but I'm going to go from the left and call that X. And then call the remaining part 24 minus X. So let's go ahead and start with that. Again, that's my X. And then if my whole length is 24, then 24 minus X is going to be from that cut over to the end. And then I'm going to say, just for the sake of setting this up, I'm going to say that the left part is going to be made into the square, and then the right part's going to be made into the circle. So it doesn't really matter. It's just going to be interpreting your answer at the end. The table there is just for you to play around with some numbers. So if you're totally lost, I always think that's a great idea, is just put some numbers in. Let's just say X is 4, or X is 10, or whatever you want it to be. Figure out what would the area of the square be, what would the area of the circle be, and add them up. And let's just kind of get a bearing of what's happening here. Is the area decreasing? Is the area increasing? We did the same problem with the box problem that we first did together when we were trying to figure out maximum volume by cutting out a square corner and folding the flat surface into a box. Okay, if we're going to try to do an equation of this, I'm going to need an equation to maximize the total area, which means I'm starting with an area equation. So my area equation is quite simply the area of the square plus the area of the circle to get my area. I'm going to call T for total. But of course I don't want to have multiple variables. So I'm going to go ahead and say the area of the square is going to be side squared. So I'm going to use an S for side. And then area of the circle is pi times radius squared. And I've got 2 variables, S and R, right now. And neither of those has anything to do with the variable that I introduced here of X. So my challenge now is how do I get, and I think we're actually going to have 2 secondary equations here. So let's go ahead and look at the square first. And what's happening is the X, this length here, is going to wrap around my square. That's going to form my square. So the equation that I'm getting from that, the secondary equation, is that the perimeter of my square is really, so we use a little s for a square, not 4 times x, give me a second here. My perimeter of my square is really x, because that length is going to go, again, all the way around to make the square. So if I know that the perimeter of the square is side plus side plus side plus side, or 4 times s, then the side length of my square is going to be x divided by 4. And I'm going to use this and now substitute that right in here for my side. So that's going to become x over 4 quantity squared is now the expression I have for the area of the square. Now let's do the same thing for the circle. So my circle, what I know about my circle is that the 24 minus x, which is the remaining part of my wire, is going to make my circle. So that's going to be the length of the circumference of my circle. If you follow what we did with the square, we're just swapping out perimeter for circumference. So the circumference is going to be 24 minus x, and I have a formula for circumference. Circumference is, of course, 2 pi r. So 2 times pi times my radius is 24 minus x, and I'm solving for radius because I want to substitute something in for this radius in terms of x. So I'm now going to say that my radius is 24 minus x all over 2 pi. And I'm not crazy about that expression, but hey, it's at least in terms of x, and I can deal with it. So that is going in for my radius right here. So I'm going to rewrite that. It's going to be plus pi times radius is 24 minus x all over 2 pi. And that is going to be squared. We do have a fraction squared there. So it is now time to do some calculus. I think you guys should be okay with that. Just be careful. You might have some chain rule going on there. We've got some powers, but we also have some change. Remember, pi is a constant. So this pi out here, nothing to worry about. You're just going to multiply that by whatever the derivative of this is. So I would go ahead and take the derivative, set it equal to 0. Just be careful with your fractions and see what you can get from this.